Here we are at example 8 from our 3.3 set of notes. We're going to go ahead and graph this system of linear inequalities. For this first one, we'll just say that he is our red inequality. And we notice that we have x is larger than or equal to negative 5. So on the x-axis, we're going to go negative 5. Put a dot there. And since there's no y value at all, y can literally be anything. We also notice that this is going to be a solid line because of that bar underneath. So we are dealing with a solid line. And again, y can be anything. Going ahead now and testing a point to shade, let's go ahead and test 0, 0, which we see is clearly to the right of our line. Is 0 larger than or equal to negative 5? It most certainly is. That is totally true. So we would shade then towards the right. Now looking at the green line, y is less than or equal to 6. We're going to go ahead and go up on our y-axis, 6. Put a dot there. There is no x, so x can literally be anything. And we also notice again, since we have that bar underneath our inequality, that this will be a solid line. So again, since there's no x, x can be anything. But y is always going to be 6. Going ahead now and testing a point. 0, 0. We see is clearly below that green line. Is 0 less than or equal to 6? It most certainly is. We tried 0, 0, he worked. That means then we would shade below our green line. Moving now onto the blue line. We have things in y equals mx plus b type form. So we're going to go ahead and plot this y-intercept first at 10. It is a little bit off the graph, so kind of just estimating. Here would be 9, maybe here's 10. Putting a dot there, and then we are going down 4 over 1. Down 4 over 1. Down 4 over 1. And so then we would end up with actually we have a dotted line here because our inequality does not have that bar underneath. So we would see something like this. Again, we'd have to test something to shade. So we can go ahead and choose 0, 0, which is clearly below that line. Is 0 less than negative 4 times 0 plus 10? So is 0 less than, this would just come out to be 0 plus 10. Is 0 less than 10? It most certainly is. So we tried 0, 0, he worked. Then all of these other points would work as well. Now moving on to our last one. X minus 2y is less than 10. We notice that this is in standard form, so we can go ahead and do a box and using standard form. You have 0, 0 on our diagonal, x and y above them. If 0 is x, essentially this is gone. So negative 2 times what gives us 10? Negative 5 would do that. If 0 is y, essentially this piece is gone. So then x would have to literally be 10. Plotting those points, because again, you've actually found a y-intercept and an x-intercept. But plotting these points, we have 0, negative 5, which is right here, and 10, 0, which would be out here. Connecting these with a dotted line, again, because there's no bar underneath, we would have something like this. Now we also have to test and shade. So we could go ahead and use our origin, 0, 0. Is 0 minus 2 times 0 less than 10? On the left side, we'll just have 0. Is that less than 10? It most certainly is. So we tried 0, 0, he worked out. That means anything above that purple inequality would work out as well. So it looks like our final shaded region would be bounded by all 4 of these, and it would be all of this area. Now we want to go ahead and look at the vertices of this. Well, this vertice with the green and the red is pretty obvious there. We see that it's happening at -5, 6. So for one of our vertices, it's happening at -5, 6. Now for some of our other vertices, they are a little bit harder to identify. So let's go ahead and look at them one by one. Let's look at, let's say, this one down here. Well, we notice that we're working with our red line and our purple line. So our red line is x is equal to -5. So just coming from this one. Again, we don't really care about the inequality because that's more of the shading stuff. We're just trying to figure out where are these two lines crossing out and intersecting. And that's why we can set it equal to each other. Or that's why we can set them instead now to equal signs. Now looking also at the purple one, we have x minus 2y is equal to 10. Now if we want to figure out this intersection, we just need to solve for the x and y that they're happening at. Well, we notice that x is already solved for, so we can take this value and throw it into our other equation. So we have -5 minus 2 times y is equal to 10. Solving for this now, we would add 5 to both sides. So it looks like -2y is equal to 15. And then dividing both sides by -2, it looks like y comes out to be -15 over 2. So in this point, this other vertice is happening at -5, because again, that was the x value, comma, -15 over 2. That's the same thing as saying -7 1/2. So notice, we kind of actually had to algebraically prove what that was, because it almost looked like it was like -5, -8. But that's why algebraic proof is kind of the ironclad, this is what it's going to be. Whereas just kind of looking at it is a good estimate if it's fair like this one, if you can clearly identify that point. But it's, again, not 100% always going to be ironclad. Now when we're looking at, we'll do this one, we'll go counterclockwise, so we'll just look at this one now. Looking at that vertice, we notice that that is our purple line and our blue line. So we're going to be looking then at these two equations. So for our blue one, we have y is equal to -4x plus 10. And our purple one, x minus 2y is equal to positive 10. Again, we do not care about the inequalities. We're just seeing where do they cross. And that's why we can change these two equations. Now, we already have one of our variables solved for. And as a result, we can use substitution method here, throwing in this -4x plus 10, which we know is equal to y, into the y for the other equation. We then end up with x minus 2 times, instead of y, it's -4x plus 10 is equal to 10. Distributing that -2, we end up then with x plus 8x. Looks like -2 times positive 10 is -20 is equal to 10. Combining our like terms and adding 20, we end up then with 9x is equal to 30. And then dividing both sides by 9, we end up with x is equal to 30 over 9. So notice our x value is not really all that nice. It's coming out to be something that looks to be maybe an intersection point, but again, that's kind of the algebraic proof behind really what it is. Now we have to go ahead and throw that back in to find out what is the corresponding y value there. So y is equal to -4 times 30 over 9. Oh, by the way, we can simplify that out. That would be, looks like x is the same thing as saying 10 over 3. So let's just simplify that out to 10 over 3 plus 10. And so then y is equal to, looks like, negative 40 over 3 plus 10. Now that we want to combine these, we'd have to do a little bit of foo. So we'd multiply the bottom by 3, because right now it's 10 over 1. We need it to be 3. So we'd have to multiply it by 3 over 3. So y is equal to negative 40 over 3 plus 3 times 10 is 30 over 3. Now that they have the same bottoms, we can combine the tops. So y is equal to negative 10 over 3. So for one of our other vertices, it came out to be 10/3, comma, negative 10/3. Now looking at the last vertice, we see that it is the blue and the green line. So y is equal to 6. So y is equal to 6. And our blue line, y is equal to negative 4x plus 10. Well, pretty much just using substitution method, we know that y is equal to 6, so we're going to throw that into the equation for our other value. We end up with 6 is equal to negative 4x plus 10. And now just solving for x here, you'd subtract 10 from both sides, leaving you with negative 4 is equal to negative 4x. Dividing both sides by negative 4, it looks like x comes out to be 1. So for our other vertice then, it is 4, wait, no, I'm sorry, 1, 6. Yeah, 1, 6. And so there are our vertices. So again, this would be graphing all of these linear inequalities, the system of linear inequalities, seeing the final shaded region, and then looking and identifying where the vertices are, or algebraically proving where they are. All right. Again, that is example 8 from our 3.3 set of notes.